my screen, we'll get started.
Sounds good.
Okay. All right. So this is the first question. It says you're simplifying square roots, and this question here is really three questions in one. It's what is the square root of 54? What is the square root of x cubed? What is the square root of y to the fifth?
Okay.
54, you should know how to break apart by now. You break it into its prime factorization, and you look for pairs. So in this case, there's a pair of threes, so it becomes 3. The square root of 54 becomes 3 square root 6. Your
Mhm.
answer to this whole thing, it's got a part outside the square root and then a part inside the square root. So we'll move those there. So the square root of x cubed, I'll just have to come off to the side a little bit more here to answer that one. This is like saying the square root of x squared times the square root of x.
Okay.
And the square root of x squared is just x. And then the square root of x is itself. So there's an x on the outside and x on the inside. Same thing with the square root of y to the fifth. This is like saying the square root of y to the fourth times the square root of y. 4 and the 1, that's how you get back to 5.
Mhm.
This should be reviewed. So if I need more detail, I can definitely provide that. But for now, I'm not going to. So that's y squared square root of y. So that's a y squared out here, and then a y on the inside.
Okay.
Is there anything you'd like me to clarify on that or go into more detail?
I'm good on that one.
All right. The next one here is, it's kind of a calculator question, but I guess your instructor could say do it by hand. Any idea if what the expectation is of this, calculator, no calculator?
We have a calculator on the whole test, so.
Okay, so you're going to use your calculator to do this. You're going to say negative 0.027 to the power of 1/3. I will point out that 3 times 3 times 3 gets you to 27. So the question is, how do you move the decimal place over? Well, it ends up being 0.3 times 0.3 times 0.3. And then the negative just means they're all negative. So the answer here is negative 0.3 for a variety of reasons. One of them, just punch into your calculator. And
Yeah.
okay, continuing down the list here. All right, so we have number 3 is the fifth root. The fifth root of negative 64 x to the 14th y to the 20th. Okay, so this is where there's a little bit more that's involved here. With the negative 64, we'll look at that first. You want to break this apart again. And you can ignore the negative because it's a fifth root. Because this is odd, you can ignore the negative. It's just going to come with it. There's going to be a negative out here. So just the 64. 2 times 32, 2 times 16, 2 times 8, 2 times 4, and 2 times 2. 1, 2, 3, 4, 5. So you're looking for 5 numbers to be able to pull one out because there's a 5 there. So there's 5 2s, which means that you can pull one out. So you have, and that's where the negative comes from. Negative 2, fifth root of whatever's left over, and there's one more 2 left over.
Okay.
All right, now this is the technique I would have shown you for the other ones. If I were in your classroom or doing a bunch of these, I'll try to explain it now. You take this 14 and you divide it by 5. And if you go back to, I'll say 4th grade, I have no idea when you learned this, your answer was it's 2 with a remainder of 4.
Yeah.
5 goes in 2 times. So the 2 tells you the power of what's on the outside. The 4 is how many are left on the inside. So the fifth root of x to the 14 becomes x squared, the fifth root of x to the 4th.
Okay.
So we can see how this works. Let me give you. Let's do the y to the 20th. So the fifth root of y to the 20th is like saying, what is 20 divided by 5? Well, that's 4 with a remainder of 0.
Mm-hmm.
So on the outside, it's y to the 4th, and on the inside, it's y to the 0 power, which this effectively is 1, because y to the 0 power is 1. The fifth root of 1 is 1. So I'm trying to explain is you just divide to get your answer when you have an exponent.
Oh, okay.
Okay, so I have to scroll up here a little bit, but because we have several parts of this problem. There's the part on the outside, and then there's the fifth root of whatever's left on the inside. So from the negative 64, you had a negative 2 and a 2 on the inside. From the x to the 14th, you had an x squared on the outside, x to the 4th on the inside. And from the y to the 20th, you just had a y to the 4th on the outside.
Okay.
If that's not clear, we can do more examples at the end if you would like.
Okay.
Okay, number four. We may not have time. We have to go through these kind of quickly to get
Yeah.
them all done in a lot of time. All right. Because these are both square roots, you can just multiply what's underneath. So you have 7 times 14, and then x cubed times x. 7 times 14 is 98, x to the 4th. And then this becomes two things, the square root of 98 times the square root of x to the 4th. So the 98 you break apart. So there's two 7s, so you bring a 7 out. It's 7 square root, and there's a 2 on the inside. X to the 4th becomes just x squared.
Okay.
Because it's 4 divided by 2, which equals 2 with a remainder of 0. So that's why the x squared there. All right, number 5. Number 5 has a lot going on in it. All right, so number 5, the instructions say something like to rationalize.
Mm-hmm.
Not sure.
Don't you just
So
multiply it by root 6x?
that's right. And then you have to do some simplifications, but on the top, it's the square root of 6x minus the square root of 18x squared over 6x. Because the square root of something times the square root of the same thing gives you just the square root of something.
Mm-hmm.
Square root of 6x, there's nothing to do there, but the square root of 18x squared, that's really the square root of 18 times the square root of x squared. 18 is 2 times 9, 3 times 3. So that becomes 3 square root 2, because there's a pair there. X squared, square root of x squared, it becomes x. It actually becomes the absolute value of x. I don't know how specific your instructor wants you to be, but that x goes on the outside. So it's 3x square root 2. You don't want to put it with the 2 because sometimes it can look like it's still under the root.
Yeah.
So your final answer is this over 6x.
Okay.
I mean, there's actually a few more things you could do here, but I think this is what's your instructor wants.
Yeah, we just have to rationalize it.
Yeah. Okay, 6 is a question that relies on you to do kind of the same skills we've just been tackling, but this time you have 3 separate problems, and then you combine the results.
Okay.
So like 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. So there's 2 pairs of 2s. So that means 2 of them come out. That's 4 square root 3. We have to do the same thing with 27, 3 and 9, 3 and 3. So you can pull a pair of you can pull a 3 out. It's 2 times that. So that's 6 square root of what's left over, which is 3. Square root of 12, 12 is 2 and 6, 2 and 3. So again, you pull a 2 out. 5 times 2 is 10, square root of 3. This is like saying I have 4 things of 3, 6 things of 3, and 10 things of 3. That means that in total there's 20 things of 3, 20 square root
Oh,
of 3.
okay. Just add them.
Yes.
All right.
Because they're all the same. Sometimes on exams they give you Like two that do add together and then one that doesn't.
And you just like leave the other
You
one
just
out.
leave it. Yeah, you just leave it off to the side.
Okay.
All right. So this one is a FOIL. You have the choice to reduce the square root of 21st. In this case, it actually is a good idea to do that.
Okay.
I can see that because it becomes a square root of 5. It becomes 2 square root 5.
Okay.
If you don't do that, you'll still get the right answer, but you just have to simplify it later.
Yeah.
So we have 3 minus 6 square root 5. We're just doing FOIL. The inner is 2 square root 5. And the last is minus 4 square root 25. This becomes a number without the square root. Square root of 25 is 5. 4 times 5 is 20. So this is minus 20. 3 minus 4 square root 5 when you combine these two. Minus 20, so that's minus 17 minus 4 square root of 5. I apologize if this feels rushed. I know that we're trying to get through all of these, and we
Yeah,
got
it's
to
okay.
kind of do 2 a minute or more
Mhm.
to stay on track. All right, 8 is oddly out of place because it's kind of straight, kind of simplistic.
Yeah.
You have the same thing under the square root in both of them. So you have 4 of them on the left and 2 of them on the right. So that means you have 6 of them together, 6, 7, x, z. Sometimes when you're doing a bunch of these problems in a row, um, you don't see kind of things like that.
You literally just add them?
You literally just add them, yeah.
Okay.
Yeah,
I don't mind that.
yeah, not too bad. Okay, this problem, it says to rationalize all denominators. The conjugate is the same thing, but with a different operator.
Oh
So
yeah.
you have to
So
modify the
plus.
operator here. Minus becomes plus, plus becomes minus,
Okay.
and you have to do that to the top and the bottom. On the top, there's going to be some simplifications. You get 5 square root 14 on the top, plus 5 square root 4 when we just multiply. On the bottom, when you FOIL, the O and the I cancel. So you really only have to do the first and the last. So square root of 7 times the square root of 7 is 7. Square root of 2 times the square root of 2 is the square root of 4. So that gives you 5 on the bottom.
Okay.
I'm going to go horizontal here. 5 square root 14, no big deal, leave that. Square root of 4 is 2, so this becomes 10. You should divide both of these.
Oh yeah. Okay. So it's root 14 plus 2.
Yes. And that's what your instructor would be looking for.
Got
Give you
it.
kind of the full credit on that one. All right. 10 is a calculator problem if you have one.
Okay.
And you said you do for this exam. So I'd like you to use your calculator. And if you don't get the right answer, I can correct it. But I guess the goal here is to make sure that you can enter it into the calculator.
Okay. Right. I got 0.04.
Yes, or 1 over 25 would be
Oh yeah. Okay.
okay. All right. Okay. What are I want to say it's for number 11? Is it 1/6 and 1/3 as the exponents?
Let me check.
It's just very difficult to see. I think it's
Oh
1/6
yeah.
and 1/3.
Um. Yeah, it's 1/6 and 1/3. Just
Okay,
came
so when
out.
the bases are the same, add the exponents.
Okay.
So this, because you're multiplying, so it's 1/6 plus 1/3. So to make your common denominator, that's 2 over 6. This becomes x to the 3 over 6, or x to the 1/2 power.
Okay.
12 is totally different, but I guess you only get one of those, kind of that, like 12 represents a kind of a challenging exponent problem for most students. You have a choice here. You can kind of deal with what's inside the parentheses first, and I think I would recommend that. It's really three separate problems. Like, what is 8 over 27? What is x to the 9th over x squared? What is y cubed over y to the 12th? So 8 over 27, even though it looks like it, it does not reduce.
Yeah.
X to the 9th over x squared is x to the 7th. Y cubed over y to the 12th, it's y to the minus 9, or the preference for me would be to have you put y to the 9th on the bottom.
Oh, yeah. Okay.
And then you have 8 over 27. We can slightly rewrite that, like 8 is really 2 to the power 3, and 27 is 3 to the power 3.
Okay.
Okay, so we still have to deal with this 2/3 power. You're applying it to everything, exponent wise. So when you, and I'll type it here because this is important. When you have an exponent to an exponent, you multiply. Sorry, I'm typing so poorly. Okay, so you multiply. So what I mean is like this 3 and this 2/3 you multiply, so that becomes 2 squared. 3 times 2/3 becomes 2, 3 times power 2. 7 times 2/3 is 14 over 3. 9 times 2/3 becomes y to the 6th.
Okay.
So your final answer here is 4 over 9, x to the 14/3, y to the 6th.
Got it.
All right, 13. So if the part inside the square root is the same, then you can just operate on it, like add it or subtract it. But it's not. 8x to the 5th is not the same as 18x to the 5th.
Yeah.
So you can't just somehow subtract this, but you can break this apart into something. So you can deal with the 8. The 8 is 2 times 4, 2 times 2. So there's a pair of 2, so it becomes 2 square root, and there's 2 on the inside. The x to the 5th, it ends up becoming x squared times x minus, now we do the same thing over here at the 18. The 18 is 2 and 9, 3 and 3. So it's 3 and then a square root. There's a 2 left on the inside. X squared x. Now you can combine them. Now you can say, oh, I've got 3x squareds, 2x squareds. So I can, because these are the same and the parts inside the roots are the same, it becomes negative 1x squared square root 2x.
All right. Not so bad.
It's easy to write the wrong thing.
Yeah.
All right, so 14 is, I think we did something like this last week. 14 is solving a square root equation. This one requires you to square both sides. So you're going to square both sides to undo the square root. So that's x minus 3 equals x minus 5 times x minus 5. You have to FOIL here. Do not just square the first and the last. You have to expand it properly.
Okay.
So we got x minus 3 equals x squared minus 10x plus 25. We're going to move everything to the right. Plus 28. So you end up getting x minus 4, x minus 7. You get two solutions. You get x equals 4, x equals 7. The instructions say to check extraneous solutions or check for them. That means that you might have one here. Yeah, you almost always have an extraneous one when there's two solutions. Not always, but most of the time. so we just have to put these numbers back into the original. So the original, we're going to check x equals 4. So that's the square root of 4 minus 3. Does that equal, question mark, 4 minus 5? So this is negative 1 on the right. This is the square root of 1 on the left. Does 1 equal negative 1? No. Check x equals 7. Square root of 7 minus 3. Does that equal, question mark, 7 minus 5? That's 2 on the right. Is the square root of 4 equal to 2? Yes.
Yeah.
So that one works. 15. All right, square root of x plus 4 equals square root of 3x. You're going to square both sides because you're trying to get rid of the square roots. That's a pretty common thing to do. So you get x plus 4 equals 3x. You don't have to square the inside part, just the square undoes the square root.
Yeah.
Okay, so you end up getting 4 equals 2x when you subtract x from both sides, so x equals 2. Let's check x equals 2. Is the square root of 2 plus 4 equal to, question mark, the square root of 3 times 2? Is the square root of 6 equal to the square root of 6? Yes.
Yeah.
Okay, so we're comfortable with our answer there. 16. Make this a little larger here. Okay, you have this 3/4 power here, and I mentioned this last time. Is it's good to kind of write, and it only applies to this. Actually, only applies to this x minus 1. So let's get rid of that 2 by dividing by it. So you can divide both sides by 2 to get 8. So this is saying that it's the 4th root of x minus 1 cubed. Is that okay?
Yeah, I remember that.
All right. So to undo this, you have to take both sides to the power of 4. Now keep in mind 8 is really 2 to the power of 3. So there's a power of 4 on the outside. When you raise an exponent to an exponent like you have here, on the right side, you get 2 to the power of 12. Now I know you have a calculator, but you could use exponents here just to make it simpler. So to undo the third power, you raise both sides to the 1/3 power. When you have an exponent to an exponent, you multiply. When you have an exponent to an exponent, you multiply. The left becomes x minus 1. The right becomes 2 to the 4th. 2 to the 4th is 16. X minus 1 equals 16, so x equals 17. Yes, you could have undone the exponent here from the original step. It works. It works because it's even, because this is even on the bottom. And I think I suggested, like, rather than try to remember, well, if it's even on the bottom, it's okay, but if it's odd, it's not. Rather than doing all that, it's better to just treat it as write it into a radical form.
Okay.
One option there. So the good news is we are basically about halfway through, and we got about half the time left. So we're in good shape to actually get through all of this. But I'm afraid your understanding might be, we're not getting enough time to really go in depth on any of these. Okay, so new question here. Before you square the left side, you've got to undo that +1. So you're isolate the root, which means that you have to undo stuff if there is things that are in the way. So you're going to square both sides. The left side becomes x plus 3 equals, and then you've got to FOIL the right. So that's x squared plus 2x plus 1. So we get x squared plus x, because you're subtracting x, minus 2, x plus 2, x minus 1 when you FOIL this. So two answers. I want you to tell me which one is extraneous and which one is not. And it's not -2 because it's negative. You've got to actually show the work because there's counterexamples to that.
Okay.
It probably is, but you got to show it for sure.
Okay, I think -2 is extraneous.
It is. It is. So it's the square root of -2 plus 3. And you should go all the way back to the original. -1, does that equal -2? So is the square root of 1 minus 1 equal to -2? Well, 1 minus 1 is 0. That does not equal -2.
Mhm.
All right, ready to move on to the next section? Okay, so for the next one, next grouping of questions, they give you two functions, and this time you have to perform different operations. So for example, in 18, it says -2 times g of x plus f of x. So they give you g of x. G of x is over here. You have to substitute that in. It's always good to substitute in parentheses. Plus, and then f of x is over here, x minus 2. So I'm also using parentheses for that one. You'll see that because there's the plus operator, I'm just going to drop them, but it's worth, for emphasis to understand, what you're doing. You're substituting all of that in for f of x. This becomes -2x squared when you distribute the -2, plus 6x minus 4. Then you got to combine like terms. So it's -2x squared plus 7x minus 6. Okay, there's no solving. You're just simplifying. There's no equal signs. There's nothing left to do.
Does that factor though?
It might, but it doesn't ask you to do that.
Oh, okay.
That's the point. Okay, now it does say to find the domain. So the domain, this is quite complicated because you have to know some things to be able to answer this question. You actually need to know the domain of the original two functions. This one is all real numbers, and this other one is also all real numbers. So that's a sigh of relief. If they weren't, that really complicates the matter. So since they started out with all real numbers, that's great. You have to look at this function though and decide, does it have any restrictions? The only restrictions you're looking for, the first one is square root of negatives, and the second is division by 0. There's no division, there's no square roots, so this is all real numbers.
Okay.
All right, the next question here, let me grab this, and then we'll do 19. So 19 says minus f of x times g of x. So again, this parentheses is really important. Negative x minus 2 times x squared minus 3x plus 2. So
Okay.
this is kind of this is a variation on FOIL. You're going to take this x and multiply everything over here. This negative can just stay to the side for the moment. So you're going to have x cubed, okay, minus 3x squared plus 2x. And then this -2, you can multiply everything. So you have minus 2x squared plus 6x minus 4. Negative still out there, so you get x cubed minus 5x squared plus 8x minus 4. Negative x cubed plus 5x squared minus 8x plus 4.
All right.
Domain, there's no restrictions on this, so it's all real numbers because the original had no restrictions.
Got it.
So 20 is, I've got to do the same thing here. I've got to grab this and then paste it below. So 20 says g of x over f of x. So f of x is x minus 2. G of x is x squared minus 3x plus 2. Just looking at this over. This one, I don't think your instructor wants you to do this, but this factors into x minus 2, x minus 1, x minus 2. So these actually cancel and you get x minus 1. But to do your domain analysis, you actually do it right here, not at this final step.
Oh, it's 2.
Yeah, it's everything except for 2. So it's negative infinity to 2 union 2 to infinity.
Okay.
All right, we're on the other side of the page. '21. All right, so this is kind of like a previous problem. If you rewrite in exponent form, I think we've done some problems where, what was I going to say? Where we went from like log to exponent. It's kind of similar. This is 5 to the 1/2 times 5 to the 1/4.
Oh, okay.
So when the bases are the same, you add the exponents. This is 5 to the 2/4 plus 1/4, which is 5 to the 3/4.
Okay.
But you have to know to do that. You have to know to convert to that form to be able to answer that question.
Yeah.
22 is similar, except it's with a variable instead of numbers. The one on top here, there's really a 2 here. So this becomes x to the 3/2 power over x to the 2/5 power. So you have to know that the bottom number in the 5 is that 5, and that 2 is on the bottom there. If you get them mixed up, I mean, it's completely wrong here. So here, when the bases are the same, and subtracting, and dividing, subtract the exponents.
Okay.
So this is a necessary step here. So it's x to the 3/2 minus 2/5, x to the, and then you got to make a common denominator. Your common denominator is like 10. So what's that? 15 over 10 minus 4 over 10. So it's x to the 11 over 10.
Okay. Got it.
'23. So this one, it says for each pair, find g bubble x and I got it covered up here. G bubble f of x and f bubble g of x. So it's the composition in both directions. So f bubble g of x means f of g of x. It means to take this one and put it in wherever you see an x.
Got it.
So in this case, it's 4x plus 1 squared minus 2. Now, I don't know if you need to simplify or not. It doesn't say. We'll skip that for the moment. G bubble f of x means to take the other one and put it in for the other x. Wherever you see an x, it's 4 times x squared minus 2 plus 1. I need to simplify that also.
Okay.
24 is more along the lines of what I think you will see for a test question, because you have to substitute it in twice depending on which direction you're going. So we'll go f bubble g of x, which is f of g of x. So that means you're going to take this and you put it in twice, this x, and put it in for this other x. 2 times minus 3x minus 1 squared plus minus 3x minus 1 minus 7.
Okay.
And again, you can simplify here. I think I'm going to not do that because we've got quite a number of problems still to do. Going the other direction now, g bubble f of x. G of f of x, it means to go the other way, take all of this and put it in wherever there's an x. So it's minus 3 times 2x squared plus x minus 7 minus 1. And again, you need to simplify.
Okay. All right, 25.
Okay, find the inverse of each function. Is the inverse a function? It's weird. Okay. The instructions are not clear. The original function does not have an inverse. The reason is that if we were to graph this, it would look something like this, and it doesn't pass the horizontal line test.
Mhm.
So that's a little weird, but that's not what I think the instructor wanted you to do here in the textbook. To find the inverse, you have to switch x and y. And when you switch them, you then have to solve for y. So subtract 1 from both sides. So you get, you take the square root, it's square root of x minus 1. It's actually plus or minus. And you get, when you subtract 3, you get negative 3 plus or minus square root of x minus 1. The reason you get this plus minus 1 is because the original did not pass the horizontal line test.
Yeah.
I don't really know what to tell you there. And if your exam is tomorrow, try to get that answered before for the test. I don't really know what the instructor wants there. Okay, 26 does not have the problem I just mentioned. It's just a matter of switching x and y and then solving for y. So we have x equals square root of 2y plus 1. So we're going to square both sides, subtract 1, and then divide by 2. So we have x squared minus 1 divided by 2.
Okay.
27. Okay. So again, you instead of writing g of x or f of x, you write y, and then you switch x and y. All of these examples, you only have to move one position, but if there was more than one x, you would make it into more than one y. So you're going to add 4 to both sides. You have x plus 4 equals 3y cubed. Divide by 3. X plus 4 divided by 3 equals y cubed. Y is equal to the cube root of x plus 4 over 3.
Okay.
$28. 28. Get back to where I can find that. Okay, 28 is f of x equals 1/4 x. See if you can do this one on your own. Let me know what you get for an answer.
Okay.
when you switch x and y and you solve for y, you're going to multiply both sides by 4. So you get y equals 4x.
Oh, okay.
All right. We should be able to get through most of these. I think we'll get through them all.
Yeah.
29 here. So it says do stuff to make it easier to graph. You kind of need to know what to do to be able to do that. Like for example here, both of these are 16 goes into both. So you can write this as the square root of 16 times x plus 5. And if you recall, you can write this as the square root of 16 times the square root of x plus 5. Why is that important? Because this square root of 16 becomes 4. And it's much easier to write the transformations of this. So there's 1, 2, 3 transformations. Left 5, that's from this. It's a vertical stretch by 4. And then it's down 1.
Okay.
So 30 is very similar. It does introduce some fractions, but it'll be okay. We'll still be able to. It'll still be the same steps. I think your instructor will choose nice numbers though. I'm not sure why I'm about to say this. Maybe I've done a few. I've helped a few students with placement tests recently. These are the kinds of questions you see on college algebra placement tests. So. They definitely are there. This one's a little bit awkward because it's got the, maybe your instructor doesn't want you to, I don't know here. Like the other way to do this is to go square root of 3 times x plus 1, and then this becomes a horizontal stretch of 3, and then it's left 1 obviously. The other way to do it is to bring the 3 out, and it's the square root of x plus 1/3. So then it's left 1/3, which is not true. Okay, so yeah, I'm going to guess your instructor wants you to go down this way, down this road, but I would probably ask 30. I think I mentioned one other one to ask, so I would probably ask just to verify that.
Yeah.
Because it's no, I'm sorry, no, that becomes 3x.
Oh, yeah.
So I'm not sure what your instructor wants here. They usually choose numbers like 29 where it works out really nicely. If it doesn't, I don't know what to tell you.
Okay.
All right. These you can all graph in Desmos, 31 through 33. Are you comfortable graphing in Desmos?
Yeah.
Okay. So the only thing that we're going to do then on these couple of problems is to find the domain and range. So the domain of a regular old radical function is this, and the range is this, 0 to infinity, 0 to infinity. So the only thing that can affect it are movements and flips and shifts. So since this goes up 3, that affects the range. And you'll see that in your graph. You'll see that the domain is still the same, but the range, this whole thing is shifted up. So it starts at 3 and goes to infinity.
Earlier.
32. So 32, we have to know the transformations here. The first transformation is that it's left minus 3/2, and this negative is a flip over the x-axis. So the left here, this affects the domain. So normally the domain starts at 0 to infinity. Well, if it goes left minus 3/2, that means it goes to minus 3/2, comma, infinity.
Okay.
The range is normally 0 to infinity. But if it's a flip over the x-axis, that means it goes from going up to going down. The range goes to minus infinity to 0.
Got it.
I think the last one here, 33, is the best example of this, and you'll see it from the graph in Desmo. It's way clearer than I'm doing. I'm kind of rushing to get this done. This one goes left 3 and then down 4. So the left 3 affects the domain. The domain was 0 to infinity, but left 3 makes it go -3 to infinity. The range was 0 to infinity, but if it goes down 4, it starts at -4 and goes to infinity.
Okay.
I will send you the notes out and the video as soon as it uploads within the next like 20 or 30 minutes. Thanks again for scheduling, and I hope this helps you on your exam.
Yeah, thank you.
You're welcome. See you
You
next time,
too.
Ella.
Bye.